Hi, grade 8s and 9s. This is the 5.1, the language of algebra. I think I'm going to do this one in 2 videos just because this one has a lot of information. So let's go through the terms and variables and coefficients and constants, all those sorts of things. Now, you were working on with the algebras the last day, right? So let's look at the idea that each of those things, right, each of those little groups that have the little squares or the sticks or the little number things, each of those, when we group them into separate groups, those are called terms. All right, terms are the variables, right? They are the x squareds, they are the x's, and they are the numbers, right? That's what my variables are. And they are connected by adding or subtracting, right? You connect them by telling me, is it a positive x squared, is it a negative x squared, all right? So for example, let's say that I have, I'm going to use this example in all 4 of these boxes, right? Let's say that I have 3x squared plus 2x minus 4, all right? So in here, 3x squared plus 2x minus 4, right? I have 3 x squareds. I have 2 x's that are positive, and then I have tiny little guys, and they're negative. Each of these are considered terms. That is, and make sure your signs go with it, those are all terms. There are 3 terms because I can group them into 3 groups. All right? Variables are the letters. Right? In this case, it's the x squareds and the x's. This one doesn't have any variables, right? So in this case, x squared, x's are my variables. Now what's in front of, so let me rewrite the question again. So I know that this thing has 3 terms. The x squared and the x are variables, but what are some of those other numbers? Well, coefficients are the numbers that are in front of my variables. The numbers in front of variables, right? They tell me how many, they're always multiplied, right? Because they tell me how many of that variable. So in this case, my variable, or my coefficients, are a positive 3 and a positive 2. Make sure your signs go with it, because it could have been a negative 2, but then that changes what they look like, right? Those sorts of things. And then there's the last thing, which is a constant, which is just a number with no variable. It's these little guys right here. It's these right there. So in the 3x squared plus 2x minus 4, it's not just the 4, it's the minus 4. It's this little thing that represents those 4 little squares. All right? So let's say that I have, I'm going to do one example here, 6x minus 7y plus 18z squared minus 2. All right? So if I go through this, I've got 1, 2, 3, 4 terms, right? I have each of those. I have, let's see, I have also variables. Let's go with my variables, right? My variables are x, right? I have a y, I have a z squared. Those are my variables. Coefficients. There tell me how many I have of them. So 6, right? Positive 6, negative 7, positive 18, right? So this one right there, the negative, make sure you is on there, and I have that. So be careful. Sometimes, like, for example, if let's say it was x plus 4, do I have an actual coefficient? Yes, I do, right? I still have that one out front. This is a coefficient. It tells me I have 1x. So there is hidden ones. Right? That sort of thing. And then the last thing I have is my constant. And not every question is going to have a constant, right? That's a constant. This positive 4 would be a constant, that sort of thing. So those are what each of those mean. So a variable is my letter, a coefficient, and it's sometimes called a numerical coefficient too, just because they're numbers, numerical coefficient. They tell me how many of the variables I have, and then I have a constant. A constant means, in math, something that cannot change, right? And the reason why this one is not a constant is because I can choose a value for x. If x is equal to 3, right, then this becomes 18. 6 times 3 is 18. What happens if x is 100? 6 times 100 is 600. It changes, right? It's not a constant all the time. But if x is 100, and I have a negative 2 off the end, is there any way that negative 2 is ever going to change? No, because I have no variable to change it, right? It's not being multiplied to anything. It's just a negative 2. I've got 2 little squares, just like I have 4 little white ones here. There's nothing I can do about that to change what that is. That's why that's called a constant, and this is a coefficient. All right? So that's the terms. Now, when we're looking at terms, we have to name them. And the name that you probably noticed, you're wondering what is a polynomial? The whole chapter is called polynomials. Polynomial is kind of like the whole name of everything. It is, for example, I married into the Sosnowski family. A polynomial is really the same thing as a Sosnowski family, right? It represents everybody that's in my family. Okay, so polynomials have one or more terms, right? But if people were just to call out Sosnowski, who are they calling? They don't, they may not want the person that responds, right? So you always call by their first names, right? We all may have all the same last names, but when I want somebody specific within my family, I'm going to say that, all right? So some polynomials have specific names. And they're the ones that we use the most, right? And that is monomials, meaning one term, binomials, meaning 2 terms, and trinomials, meaning 3 terms. And then anything that is generally 4 or more terms, we just call a polynomial. All right, so for example, if I had 2x to the 3 minus 6x squared plus 7x minus 4. 4 terms, polynomial. All right, as soon as I get 1 term, 2 terms, 3 terms, then I like to call them by their specific names. All right, so a monomial is 1 term. And remember, it is 1 term because it contains no adding or subtracting. As soon as I have adding and subtracting in it, right, I get from term to term. So for example, we all know that 6x squared, 1 term. I can have fractions as my coefficient, right? None of that is adding or subtracting. It's negative. I can have constants. Constants are always monomials. I can even have letters pushed together through multiplication, right? A, B, C, D. I could have the whole alphabet strung together as long as it's multiplied. All right? As soon as I start putting adding or subtracting signs in, I move up in number of terms, right? I could go A times B plus a C. Now I'm in 2 terms, right? I have an A, B, and I have a C. If I want to make that a 3-term one, I could go A minus B plus C, right? As soon as I put adding and subtracting signs in, it tells you how many terms there are. There is an A term, there's a negative B term, and there is a C term. This looks very different. Whatever this object is, it is an A, B, C. All right? And even with dividing, I could have 8 divided by x or 8 divided by x. Still only 1 term. As soon as I go 8 plus x, right, it becomes a binomial. All right? Those sorts of things. So other binomials might be negative 6a plus 5b, right? 2 terms. Or 7x minus a 5, 2 terms. All right? 3 terms, trinomials. 2x squared plus 3x minus 4, right? W plus a 4y minus 17z. Doesn't really matter what it is, right? As long as it's connecting with adding and subtracting, we have distinct terms. All right? That sort of thing. All right. I'm going to stop there on video number 1 so it's easier to upload to YouTube, and I'm going to do video number 2 right away here, and you can continue on with video 2. All right, join me for video 2, guys. Bye.